Hello, welcome back everyone. So this is Naghmana. I'm going to do Spec Maths Exam 1. So we're up to question number 6. If you haven't watched the other videos, you can go back to the other previous questions on the other videos. So let's see what we got in this question. So we have the first thing we need to look at that this question was worth 4 marks. So we need to provide as much detail as we can in there to get the whole mark in there. So let's try to understand what is the given. So we have 3 vectors, A, B, and C are given, where P is a real constant. Find the value of P for which 3 vectors are linearly independent. So we're looking for those P values, which will make that linearly independent. Okay, so what is the condition we know when the vectors are linearly dependent? Okay, so that would be like let's say we have a C vector, which could be written as, or one of them is written as the linear factor of the other 2 vectors. So what we do in this one, we go and see if we can write that as a linear factor there, because we're working that out what value of P will give us that. So like, let's say if I say that is equal to M times A plus N times B. So we use this. So we get C is 3I plus 2J plus 1 minus P square K is equal to M times A, which is M minus I plus 6J minus 3K. Write all of them. Okay, so we written it like this. Now I'm just going to compare the coefficients. So if we write that as an I component on the right-hand side, we get negative M plus 2 is I component plus 6M minus 8N J, and we get the same. We get negative 3M plus 5NK. Now, if we compare the coefficient, what we get is negative M plus 2N equal to 3. I component with I on the left-hand side and the right-hand side of the equation. And then we have 6M minus 8N is equal to J. And then we have 1 minus P square is equal to negative 3M minus 5N. Okay, so if we do solve this simultaneously, if we look at that, so sorry, this should be 2. I was meant to write that 2 instead 2. Okay, so we have these 2 has M and N in it. So that's like simultaneously you can solve them and find M and N. So if we do that, so we're going to get is we could do times this by 4 and subtract. So we get negative 4M plus 8N equal 12. And then we add them together, we get 2M is equal to 14. This gives me M is equal to 7. If M is equal to 7, then this will give me negative 7 plus 2N is equal to 3. So that means 2N is equal to 10. That means N is equal to 5. So we got N is equal to 2 and N is equal to 5 and M is equal to 7. Now let's see what is. This would give us 1 minus P square. Absolute value of that is minus 3 times 7 is 21, and then 25, 21, 25 would give us is 5, and here is a plus. So we're saying we have negative 21 plus 25. That will give you 1 minus P square equal to 4. Okay, so what we know now, so because this is like 1 minus P square, it's absolute value function, which gives you plus minus 4. by definition of that. And then we say P is in all real number, right? So then that means P squared is equal to 1 is equal to 5, right? Can't be negative value, so we ignore the -1. So P is equal to square root of 5 plus minus square root of 5. So what does that mean? These values where P is plus square root of 5 and minus root 5, they give us when these three vectors are linearly dependent. So what we can say here is it would be linearly independent if P is all real number except we take these two numbers away, negative root 5 and positive root 5. So that should be the answer of this question. And I think it's a worth 4-mark question. A bit of working, but it works. Okay, now let's look at the question number 7, which says the velocity of the particle satisfies the differential equation dx over dt is x sine t, where x centimeter is a displacement relative to the fixed point O. Initially, the displacement of the particle is 1 centimeter. Find the expression of x in terms of t. So dx over dt is given. So derivative of the x is given. To find out and the x in terms of t, what we need to do is we need to anti-differentiate it. So can I write it like this? Dx over x is equal to sine t times dt. And then we can do anti-differentiate it. So that will give me log ex is equal to sine t will give me minus cos t plus arbitrary constant. Okay, so now what we say when the initial, in terms of the t, when the particle initially, the displacement of the particle is 1 centimeter. So what does that mean? So that means when t is equal to 0, x is equal to 1. That's what it means. Now we can use that condition. It will give us log E1 is equal to minus cos of 0 plus c. Log E1 is 0, so cos 0 is 1, so that gives you c is equal to 1. So we got that particular value of the constant. Now that means the answer should be log E x is equal to negative cos t plus 1. So we can now write that as because the one thing we need to make sure that this x here is the positive, right? Because the log is defined on the positive number. So then we got to write that as x because we need to give an expression for x. So we're going to do just rewrite using the definition of the exponential. So we go e to the power 1 minus cos of t, x is equal to 1 minus cos of t. So that will be the x we got, which satisfy the condition of using the 0, 1. Okay, now we need to find out the maximum displacement of the particle and the time at which this occurs. So we know what x is now. We want to find out where is that maximum happening. So let's do this one. So for that, we need to do is dx over dt, right? So dx over, because our x is, we just got x is e to the power 1 minus cos t. We can use that. Dx over dt is equal to e to the power 1 minus cos of t, right? And then the derivative of negative cos is sine t. And then we say this first derivative equal to 0, because that's how you find the maximum or the stationary point on that one. So let's see what we get. So this means e to the power, and therefore we can say that e to the power 1 minus cos t can never be negative. So that means the sine of t has to be 0. If the sine of t is 0, so that means t has to be this one, we say, therefore t has to be either 0, pi, 2 pi, 3 pi, and all of the multiples of pi give you 0. So what we're saying is x would be equal to what? We said that is x is equal to 1. Okay, so when x is equal to 1, right? So that means what do we get? So all of them, when t is 0, x is 1. When t is pi, that is equal to x is, when t is pi, x would be e to the power 2. And then when x, this is 2 pi, that is equal to, again, it is equal to, that is e square, and that is give you e square as well, and e square as well, and e square as well. That's how it is going to go. What does that mean? That means you say maximum, x maximum is e to the power 2 when t is equal to pi to 3 pi, and so on. So because when it's 2 pi, it is, sorry, so I think I just messed it up a little bit. I think 3 pi is okay. When e is equal to 2 pi, that give you 2 pi and is 1. So 1 minus 1 is 0. E to the power 0 is 1. So that give you 1. I forgot to write the 1 of the 1. So e square would be the maximum value of the x in the displacement.